Hey, what's going on, everybody? This is Brett Hall, and today we're going to talk a little bit about software-defined access and the architecture itself, and also how to deploy Cisco Emergency Responder so that it enables E911 capabilities over the top of a SDA architecture. So two things real quick. If you're a voice guy, you're not that familiar with the SDA architecture. Essentially what it is a way of putting a centralized controller on site at a campus environment and centrally managing all your network devices to help you scale, to help you do things more effectively in a centralized fashion. Part of this SDA architecture involves a fabric, which means you're able to secure things on the fabric as they come on, as users come on to that network fabric more efficiently, and also allows you to distribute network type of parameters more efficiently as well. So essentially decoupling the location from your access policy, if that makes sense. So your access policy is now defined by how you authenticate on the network with things like Identity Service Engine, with ICE, and with your segmentation or your microsegmentation policies within DNA Center. If we have time, we'll take a look at the screen in DNA Center. The other thing is E911. And so the traditional way of deploying a emergency response location to a building through an IP subnet is no longer a reliable way of assigning the ERL, because with SDA, the IP subnets are stretched across this new network fabric that we're creating. And so we have to look at other ways of creating a ERL so that we can comply with BAUMS Act. And BAUMS Act, if you're not that familiar with it, it basically states that emergency services personnel, they need to have a dispatchable location that they can send people to. So no longer do you send somebody to the front of the building or the gate if you have a large campus environment. You actually have to have a, no kidding, reliable, building number, if you will, so they can go to that location and respond in a quick, rapid fashion to do their jobs. So if you're interested, there's also Kari's law, which went into effect this year, and Kari's law states that when someone's dialing 911, they should not have to prefix 911 with a 9. I know a lot of organizations do require you to press a 9 or an 8 to get an outside line. So make sure you're compliant with that. And in the latest code, Cisco does a good job of telling you whether or not you've configured a route pattern that has 911 in it so that you can comply with Kari's law. But for the most part today, we're talking about BAUMS Act and the implications of deploying 911 or E911 solutions over the top of SDA Fabric. So let me try to explain the challenges of SDA. Again, if you're not a network guy, this may be interesting and helpful for you. So I have this DNA Center interface up here on the screen. And let me just go ahead and zoom in a little bit for you so you can see what this large campus environment looks like. And this is just a sample. You can see there's a lot of different buildings here depicted on this map of this certain screen. In this particular example, I have 4 different types of buildings. I have 659, 812, 649, and 817. And so typically those buildings would all have unique layer 3 IP addresses and IP subnets that you would just assign to those buildings and use that as an ERL. But with the SDA Fabric, the fabric uses something called Anycast Gateway, and like I said, that kind of decouples the idea of isolating a single IP subnet from a certain building. what it does, it essentially, makes every network device the same. The subnet live on the same network device. The same subnet live on each and every network device across the entire network, leveraging Anycast gateway. So what I'll do here is I'll show you what I mean. And I'm logged out of these network devices, but it's not really a big deal. So I have Edge 3. I have the switch Edge 3 here on my left, and I have switch Edge 4 on my right. And so just to kind of orient you a little bit, let me pop over to the Fabric page and show you my topology. So this is my topology, okay? I'll zoom in a little bit. This is my access layer switch. I got Edge 3 right here, and then I have Edge 4 here on the right. And in any case, as you can see here on my screen, if you look at the interface, if you look at the running config of this interface, you can see the IP address is 10.55.11.1. And if you look at the Edge 9K4 switch on the same VLAN interface, you can see that the IP address is the exact same IP address. So any client that plugs into either of these switches, 9K3 or 9K4, is going to use this 11.1 IP address as their default gateway. And how traffic gets routed across the fabric is a separate conversation. But under the covers, it uses something called Location Identification Separation Protocol. It uses Lisp. And that's how, it's able to kind of route a packet from point A to point B. But this is key because, this is the kind of environment that you may have to work with to deploy E911 over. And so when you look at this, hopefully this kind of helps you understand why you can't use IP subnets any longer, because they literally live everywhere. They live on every single network device across your fabric. So the only really option you have with deploying E911 over an SDA Fabric is to use the physical infrastructure. And so when I say physical infrastructure, there are two ways to do that. In order, right? You have, I'm at Cisco Emergency Responders webpage right now. You have your switch ports, the physical ports that belong to your network device, and then your access points. So within, I think 11.5, Cisco came out with a feature called Enhanced Location Awareness. And what that essentially means is that any kind of Jabber for Windows device that is connected over the network, you can assign an ERL to the specific access point that we know resides in a certain portion of the building. So those are the only two ways to do it. IP subnets is no longer really a viable way of configuring an ERL. And so, if you're not familiar with configuring ERLs within CER, it's very, very straightforward. Real quickly, I'll show you how to do that. And I'll point out one thing along the way. And so one thing that's unique in the switch infrastructure's configuration is the loopback address. So each network device has a loopback address that's unique to it. And so when we add network devices into Cisco Emergency Responder, we're going to leverage those loopback addresses to onboard them to the database, the CER database. And that can be done here under LAN switch details. And so you can see I have 3 different LAN switches that I've added manually. Certainly you could wildcard this, but I've added these devices manually. And for the moment, I'll switch back to switch ports just so you understand what's going on technically under the covers. I have devices registered to call manager that are plugged into very specific network ports. And so if you look at this 101 switch for a second here, this 101 switch is an 8865. It has the IP address of 1055.11.52, and the phone number is 1001. And you can see here it's plugged into port gig 1013. And that port has been assigned an ERL of building 812_1FL, signifying the first floor of building 812. So if for some reason you needed to change something, it's pretty straightforward. You can search for an ERL. I guess I have 4 configured. You can select something that you want to reassign with, and then highlight the box that's hovering over, like, the port, gig 12 in this example, and then hit assign. So you can see just like that, I reassigned port 12 to building 659. So I'm just going to go ahead and change that back real quick though, because I don't want someone to plug into that and think that they got routed to the wrong environment by accident. So that's how that works. There's 2 different protocols are involved here. Our Cisco Discovery Protocol. This is what the switch uses to determine that this is an 8865 plugged into its network port, and all the relevant details like the IP address that's able to gather. And then SNMP. So CER supports SNMP 1, version 2, version 3, whatever you use, it can up to you and your security policy. But at some point, once you have all your LAN switches onboarded, CER will go out and pull those LAN switches using SNMP and populate its database here on a screen so we can look at it and configure it. From a compliance perspective, I think one interesting screen for you to look at, or maybe I'll show you 2, is this ERL debug tool. And you can see here just real quickly what ERLs all the phones would use if they called 911. And then you have your call history. So this call history is what gives you the compliance check for BAUMS Act. But as you can see here, we have the different ERLs associated with a 911 call. You have the caller's extension, and as you can see here, I've made a bunch of test calls. But you have the timestamp, you have the date, and then you have your route pattern, which I'll explain here in a few minutes. So this is compliance. If I go back over to one more screen here, I'll show you the ERL configuration. And that's pretty straightforward. It's here under ERL and conventional ERL. And I'll just pull up all 4 of them for a second. I'll pick on 812. So part of E911 is the ability to, especially if you have a large campus environment, it's the ability to route a call to the right PSAP, to the right public safety answering point. And if you have a large campus environment, that campus environment may very well span 2 different PSAPs. So you may want to have a specific route pattern or a translation pattern, depending on how you route the calls, associated with a certain ERL. And it's these specific route patterns that allows you to drop down to a specific route list and a route group, and ultimately a gateway that routes the call out to the PSTN. So that's one thing that I get questions about all the time, is how do you steer a call out to the right local PSTN gateway? That's how you do it. The other piece is around ELIN, and ELIN is an acronym that stands for Emergency Location Identification Number. And so this is used for exchanging the location of these ERLs with the PSAP. And so this is a 10-digit number, so it's actually already it's also used for the PSTN to call back someone that called 911. So imagine for a second someone called 911, they passed out, and they were trying to figure out, like, hey, what was wrong? Like, did they have a stroke? Are they having a heart attack? Like, what's going on with this patient, so that when my guys are on the scene, they can respond appropriately. They should already have the location information, because they're gonna take a look at the caller ID and cross-reference that caller ID in their database, in their ALI database, and so they're gonna already know where to go, but they might want to know what's going on with this person. And so they could potentially use this 10-digit ELIN to return the call, and hopefully somebody answers, and they can talk to that person, so that when they arrive on the scene, they have the most situational awareness as possible. So this is ELIN, and you want to make sure, if you're developing or designing an E911 solution, you have plenty of ELINs for all of your ERLs. And so if you have, this is a separate design tangent that I don't really want to talk about, but if you have 100 ERLs, you're going to want 100 ELINs to associate to those ERLs. Maybe even maybe you want 2 ELINs per ERL in case there's a mass issue like a fire. You might have more than one person call 911 at a time. So by associating 2 ELINs to an ERL, you have the ability to get more information to associate a location to. As far as E911 goes, ERL and ELINs are 2 important terms to understand. One thing that's unique about CER, Cisco CER, is the ability to also generate a local notification. So at many large environments, there are security personnel that are providing security to, I don't know, reduce crime or whatever. But oftentimes these security guards, these personnel, are trained in things like CPR. And so it may make sense, since they're already on scene, they're already like walking around the campus somewhere, to call somebody locally, so they can rush to the building, maybe start administering CPR, maybe to talk to the PSAP personnel, so that, again, when they arrive on the scene, they can have the most situational awareness. When you create your ERL, there's also something, like I said, the very specific information called the ALI information. Stands for automatic location information or identification. I forget which one. But this is where you fill out the very specific address of your building, right? Like what are all the parameters here? And at some point, you'll take all this ALI information and share it with your PSAP, so they can import it into your PSAP database. E911 is obviously, it's sharing the ALI information, but what I always tell people about CER is it's dynamic, and so one of the benefits of voice over IP is you should have the ability for anyone to unplug from a network port, move their laptop around or their phone around, and plug in somewhere else to get connectivity. So I see a lot of customers, thinking that static compliance is true E911 compliance, and I think that could be ripe for failure, because if someone is statically configured in database, but they unplug their phone and move to a separate building, maybe they've been reassigned to a different team, that's a real way and a real risk of potentially having a PSAP dispatch emergencies people out to the wrong location. So hopefully this information was helpful for you, and hopefully by now you understand how CER can support E911 solutions over the top of a SDA Fabric. I say over the top, I should say under the covers, because really what we're doing here with SNMP is we're pulling a network device using the underlay infrastructure, the loopback IP address of the network device. It's not participating in the SDA Fabric. But hopefully, and in any case, hopefully this information is helpful for you. and you'll take it to deploy E911 safely across your organization. If you have any questions, feel free to drop me a note in the comments section. And if you like it, feel free to recommend this video to somebody else and hit the like button. Hope you have a great day, guys. Talk to you soon.